Hi there! In today's video I'm going to create this puzzle game in C with Raylib, where you can load your own image and it will be converted into a puzzle, and then you can move these puzzle pieces around, and when you get the correct ordering, then it will bring the pieces together and it will look like this. So if you want to see how I did it, then watch this video. Let's get started. Let's start by just creating a main.c and creating a hello world program here, because again I haven't coded C in maybe a month or so. So we need to include stdio.h, and we have to have an int main in which we have to return 0 to indicate 0 problems, and before that we have to print f hello world. But I don't want to use Copilot today because I am actually trying to learn C, so let's turn it on if we really need to. But this should be hello world in C. So then we can compile it with gcc o main for output and main.c. And now if we run main, then we get hello world. Amazing. But I want to use Raylib, so let's do hello world in Raylib. So we're going to include, damn Copilot, how can I disable Copilot? Disable for C. How about now? Okay, now we don't have Copilot. So we want to include raylib.h. And instead of doing hello world, we are going to make a loop. So while not window should close, we are going to do the following. We are going to begin drawing and we are going to end drawing. And we actually should also set here the FPS. So set target FPS, let's call it 60. And let's get rid of this extra white space because I'm used to coding like this in PHP, so I add lots of white space, but then somebody's gonna complain in the comments. Anyway, between begin drawing and end drawing, we should actually draw something, because otherwise we are lying. So let's clear the background here and let's use black as the color. And that is already considered drawing, so that is enough. And in the end, we should do window close or close window. So that should be hello world in Raylib. So if we then run gcco main.c again, we actually get an error because we have to include the Raylib in here, the Raylib library. So if we run this, then we get no errors. And if we now run main.c, then we get a segmentation fault. And that is because we have to initialize the window. So here we have to say init window, and we need to give it the width. Let's put 800 by 600, and that should be hello world in Raylib. And we still got an error. Init window, because I forgot the title. Let's add a title. Puzzler. And then if we now run it and we open it, then here we have our puzzler game window. Amazing. But since we want to make a puzzle, we should load an image here, which we can turn into a puzzle. And I conveniently have an image here already of some random dude off the internet. So I'm going to use this as the puzzle. So let's try to load this image. There is in Raylib a function called load image, which we can use to do exactly this. And it takes the file name, and the file name is dude.jpg. And we of course have to set this to a variable, and this I believe returns an image. So image, let's call it image, equals that. And in order to draw an image, I believe we had to convert it into a texture, which I guess is something that is run on the GPU instead of the CPU. So we have to say texture 2D, I believe. Image texture is going to be load texture. From image, I think we have this thing. And then we can pass in the image here. So let's do that. So now we have a texture. So then after clear background, we can draw the image here, which we can do with draw texture, I presume. Texture. Okay, now we have draw texture X and draw texture N patch and Pro and Rec and V. Okay, let's see what just draw texture does. It takes the texture and the position. Okay, so we can do this. Let's do this at first. So image texture is going to be passed here, and position is 0 and 0. And the tint is just going to be white, which basically doesn't do anything. But if you put another color here, then it will change somehow the color of the image. But now, if we run this again, so we build it and then we run it, then we get an error. Data format not supported. Failed to load image data. Data is not valid to load texture. And I believe the reason for this is that Raylib doesn't support JPEG. So let's convert it into PNG. Convert dude to dude.png. And then we can use PNG here. And let's try to compile it again. And let's try to run it. And look at this. We have the image here. But we want to resize it to the window. So how can we do that? I believe here we have to then use some other function than draw texture. So we can probably use now the X or Pro. I'm not sure. Let's see. X takes the texture and a vector position and rotation and scale. Yes, but I think there was even a Pro version. And this one takes the texture and the source rectangle and destination rectangle. And then origin, rotation and tint. So I believe what we can do here is we can define as the source rectangle the whole size of the original image, and then the destination rectangle as a piece of the window. So let's try to do that. So we need to have a rectangle of the image. Let's call it image rec. And I believe we could do something like this. We can say rectangle, and how did this work? Do I just do this or like that? No, this has to be in parentheses, and then I can do this. And what does a rectangle have? Let's go to the definition. We have x, y, width, and height. So the x is going to be 0. Can we just do 0, 0, and then image dot width and image dot height? Okay, so this is going to be the image rectangle, which we have to pass in here as the source, image rec. And then we have to have the destination rectangle, which basically it could be just 800 by 600. So we have to create a rectangle. Let's create that. Let's say rectangle image rec resized. And this is also going to be a rectangle. But here we technically could just use 800 by 600. Let's do like window width like this and window height. And let's define them here. Int window width is 800 and int window height is 600. And then we can define them here. Window width and window height. Now I guess these don't really need to be variables, so we could move them here and we could just define these. So let's say define, and these should be uppercase, and we don't need the equal sign here. And I guess there is no semicolon here either. And then the window width is going to be window width like this, and window height is going to be window height. Okay, so if we then pass in here the image rec resize, and we have the origin and rotation. So rotation is just 0, and origin is a vector 2, which is just going to be 0, 0, I guess. So do we really have to define this, or can we just do like vector 2 and how can we make it 0? Can we do just this? Sorry, this should be 0. This is a massive line. And I mean, technically, I think we don't need the other 0 here, but we could do that. So now, if we build it and we run it, then look at this. We have resized the image, but as you can see, it's kind of stretched out. So instead of using the window width and window height, we should calculate the actual width of the image based on the window height. So let's do that. Let's say that the height of the resized image is the window height, but the width is going to be something else. Let's just call it width. And what is width? It is going to be the ratio between the original image's width and height. So image.width divided by image.height. Or maybe the other way. I never remember how this works. Let's just try. Does it work like this? And sorry, we have to, of course, do times window height. Yes, so image width of image height will be the ratio how much the image width is of the image height, and then we just times that by the window height. So then we should keep the aspect ratio. So let's compile it and let's run it. And clearly I did something wrong. Let's see what went wrong here. Perhaps because I used an int as the width, then when we divide, then this will be converted to an int already, which is going to be 0. And then we're going to do 0 times window height. So this should be a float. And does this take, I think this actually takes a float, right? A rectangle takes a float. Okay. So let's try to compile it once more and run it. And it still doesn't work for some reason. Why not? Let's do just printf d and the width. I mean, I guess it has to be f because it's a float. And let's see what it actually is. Okay, it is 0. How is it 0? Is it still converted into an integer even though this is a float? Well, window height is of course an integer. So do we need to cast the window height into a float? So then it will keep it float. Let's see. If we now run it, it's still 0. Okay, so why is it 0? What if we do just this? Image width divided by image height. What is this? 0. Am I stupid here? I'm probably stupid. Width is image width divided by image height. What is image width? Let's do this. Okay, we have a width. That's fine. And what is image height? It is. We also have a height. So what is wrong here? If we do this, then for some reason it's 0. Is this an integer? It is an integer. So do we need to convert these into floats? Really? And then if we run it and we open it, okay, now we have 0.72. Okay, you learn something new every day. By the way, if you haven't noticed, I'm kind of a newbie in C. Okay, well, now I know. We have to convert these into floats, and then we can do times window height, which I guess, does this need to be a float then as well? Let's see, if we now run this thing, okay, seems to work, but is it too narrow? I'm not 100% sure about this. Let me open this. Dude. Okay, it's yeah, he's just a narrow guy. Okay, that's fine. So now it works. I really want to know, do we have to convert this into a float as well? And if we then run, it still works. Okay, so only with the division for some reason. Okay, anyway, I spent way too much time on this. Now, what I actually might want to do is I might want to initialize the window here and just use the width this way. So the window will be actually the size of the image. So let's not even define the window width, just the height. So now if I run this thing, we get a segmentation fault for some reason. Does the window need to be initialized in the beginning? Or is it now because this needs an int? Let's make this an int width and then do this. Damn it. Let's keep it this way. So we will make it a certain size, but I want to center the image, which means we need to change the origin. So the x of the origin should be the window width divided by 2. So then it will start from the center. But then we have to move it back by half of the width of the image. So then we have to minus the width divided by 2. And I don't think we are going to have any issues here with the floats because these numbers are pretty big. So let's run this now. And why did that happen? Wait a minute. Okay, if we just move it by the window width, it is going to look like this. What? Why? Why would it look like this? If this is 50, then it will look like it moves in the wrong direction. Ah, it's the origin. It's not the position. Okay. So this is kind of where we start drawing the image from. And if we have a rotation, where we rotate from. So this is still going to be 0, 0, but we have to actually move it with this image rec resize. So this X and Y is going to be the position. Okay, so here we have to do window width divided by 2 minus width divided by 2. So let's do something like this. And let's try again. So now if we run it, now we have a centered image. Great. 30 minutes to center an image in Raylib. Now we need to break it into pieces. So how do we do that? I guess because we are using this Draw Texture Pro, which takes the texture and then the rectangle of the origin of the image, and then the rectangle of the destination. Then we need to just call this function many times, but with different parts of the image. So we have to have some loop. Let's make a loop. Let's do a for loop. And in the for loop, we are going to have an int I equals 0 and I less than what? We have to decide how many pieces we're going to create. So let's say num pieces, I plus plus. But we can't really separate the image into arbitrary numbers of pieces, can we? Because we have to cut it. We have to cut it at least 2 times. So then there's going to be 4 pieces. So what is the setting? Because I want to have like a difficulty level. So I guess it's like, it can be 4 by 4, 5 by 5, 6 by 6, and so on. So let's define here like an x by x. And let's say 5. So then we can do something like int x is 0. Or I guess we should start with y, so we go row by row. So while y is less than x by x, I don't know what is the name I should use here. Maybe grid size. Grid size, let's do that. And y plus plus. So this will loop through each of the rows. And then here we have another for loop. Int x equals 0, x less than grid size, x plus plus. And here we are going to draw the texture. And we're going to use the image texture. But then what is now the image rec? We need to calculate the size of the piece. So let's do that. Let's do int piece size. And we need to have a width and a height. So maybe this can be a vector too. So we have to do it this way. And then we can set the first element in this vector, which is the width, to width divided by 2. So this is the image width, the resized width of the image. And the height, sorry, not by 2, divided by grid size. And then this is going to be the window height divided by grid size. So this is the size of the piece we want to draw. Okay. And I have an error here because this is actually now a vector 2. And is this even necessary? Because we define a vector 2 here. Can I just do this? Maybe I can. But let's do it this way anyway, because that is how I have seen it done. Anyway, then we have to create the rectangle. So let's call this a rectangle piece rec. And this is going to be a rectangle. And the position is going to be x times piece size dot x. So when we're in the upper corner, the x is just going to be 0 because x is 0. But then the next piece in this row will be after the previous piece because we use the x of the piece size, which is the width of the piece size. Okay. And the y is going to be the y times piece size dot y. Now I want to have some sort of padding, I guess. So let's add a padding, which we can define, I guess, here. Padding is, let's say, 5 pixel. And a rectangle will have also the width and the height. So what are those? Well, the width is just the piece size dot x and the height is piece size dot y. Okay, so this is the rectangle. that we want to have as the source from the original image. So let's put it here. Now, where do we calculate this from actually? We calculate from the width and the window height, which I think is not really going to work because this rectangle has to be a piece of the original image. But then the piece resized should be the size relative to the actual window. Okay, so we have to account for that. But let's create that first. We have a piece rec and we have piece rec resized. And then this is going to be piece rec resized. Okay, but now they are the same, which is not going to work. So how should we do this? I guess we could just have two things here. So we have piece size. I guess we could call this source and piece size dest. So the source is going to be the actual width of the image. So we have to use this and the actual height of the image like this. And then the piece size dest is going to be exactly this. So this is the calculated width of the image, what it should be, and the calculated height, which, well, actually it's just the window height. Okay, I think that should work. Here we have to say now piece size source, and here we have to say piece size dest. Okay, so that should now work. Let's see if it works. Let's compile it and let's run it. And we still have an image here, which we shouldn't really have. So what is going on here? I can see some weirdness going on in there. So how come we draw the whole thing? Piece rec and piece rec resized. Maybe my padding just doesn't work. So we add the padding to each of these, but we shouldn't add it to the source because we do have to get every part of the image copied into the screen, but then when we copy the part to the screen, then we add the padding. So then there should be a little bit of padding there. Maybe that's the problem. We just drew the image so meticulously correctly that it looks like we just drew the image. So let's compile it and let's run it. And that did not work at all. Okay, let's do this. When we are in the loop, let's just, let's break after the first line. What will happen now? Okay, so we are drawing it piece by piece, but the padding doesn't work. Is that the only reason here? So padding is 5 pixels and the destination is always plus padding, but this should be padding times X, right? So now we just moved the image 5 pixels to the right, but then, okay, every other piece was moved the same amount, so there was no padding. So we need to have the padding here times X. But this is not centered for some reason, and that is because we are not doing this anymore anywhere. Are we using this anywhere? We are not using the image rec resize anymore. So let's copy this calculation and let's remove that thing, and we are going to put it here. So the X is actually going to be this plus X times p size test. X plus padding. Okay. So this is kind of the X origin of the image we want to draw on the screen. But since we have the padding, we should move it back even more. So let's call this something like X origin. And let's do it here. Or in fact in here. Int X origin is this one minus padding times grid size. Right? Because we have to remove the padding. But not for the last piece. So this has to be -1. So now, if we compile this thing and we run it, then it almost works. What's going on up here? Okay, I forgot to put it in the y-axis. So what did I put here? It's still y times piece origin test y plus padding. This should be times y. Okay, so let's compile it one more time and run it. Okay, we have now pieces. And I'm going to make the window a little bit bigger so that you can see it a little better, which I probably should have done from the beginning, but whatever. Let's put 1,800. And let's open this. Okay. So now what we have to do is we have to shuffle the pieces. How do we shuffle the pieces? It seems like it should be pretty easy. But then again, this is C, so how do you shuffle in C? So basically, we have a bunch of origin rectangles and destination rectangles. And then we just have to draw all of those. But we should take another origin than the actual corresponding origin in order to shuffle them. But we also want to track the correct order of the pieces. So I guess we should have some sort of array where we have the current ordering of the pieces. So can we make some sort of array which is like the ordering? And since we know how many pieces, we can just say grid size. And it will be a two-dimensional array, so we have to have another grid size here. And as we draw it, when we put a piece in the grid, we can say that ordering index, let's do x, index y, is going to be what? I said it as an integer, but this should be like, we should save that in this xy position, we have this xy position of the original image. So can we make this a vector 2? And then we can say that this is going to be a vector 2 of the x and y. So then we know what piece in the grid corresponds to what piece in the image. And what if we actually just generate the ordering like this? And then we have another loop that goes through the ordering and then draws the piece in the position in that ordering. Now we're going to have two loops, but let's see how is this going to work. So then the piece is going to be this. Vector 2 piece is that. And then instead of just using x, we are going to use piece.x. Right. So if we do piece.x and piece.y, and here also piece.x and piece.x, piece.y, piece.y, then isn't that going to work exactly the same? But now we have this array that we can reorder, and then we can print whatever is in that array. So this in fact doesn't have to be in the loop, we can just do it here. Okay, let's do that and see if it still works. Let's build it and let's run it, and we still have the same thing. Okay, but how do we shuffle the array? Now I think is a good time to use ChatGPT, because even though I've been programming for like 20 years, I haven't been programming in C for 20 years. So I've never come across the problem of shuffling, because in the higher level languages that I've used, you just have a shuffle function and it just shuffles whatever you give it. So let's ask ChatGPT, how can I shuffle an array in C? To shuffle an array, you can use the Fisher-Yates shuffle algorithm. Okay, so what does that mean? We have a void shuffle that takes in an array and the size of the array, and if the size is more than 1, then we loop through each of the elements in the array backwards, and then we get a j, which is rand modulo I plus 1, and then we make a temporary variable from array index I. We set array index I to array index j, and then array j into 10. So basically we swap the values. Okay, so how does that work? So j is going to be a random number from 0 until I plus 1, which is, on the first iteration, the last element of the array, and on the next one it's the next to last element. So we're kind of making the pool of choices smaller with every iteration, and we take the choice that we got, the random choice, we take a random element of the array and set it to the current element that we are looping in. And then we set the random element that we picked and we put our current element there. So this is the current element which we save here and we put it to the randomly picked spot. So we swap them. So that solves the issue that we are not going to pick the same element multiple times because we always swap with the one we picked. Okay, I think I can implement this myself when I look at this first. So this is shuffling it in place. It's void, so it will shuffle it in place. But I want to keep the real ordering here. So could I make a shuffled version and at first just set it the same thing, so shuffled, and then we need to again loop through each item in the shuffled array. So let's do this, and what we're gonna do is, we have to loop backwards. Okay, I guess we can loop forwards too, but then this is going to change. This just has to be like I minus a random number from 0 to, or from I to the end of the array, right? So let's include stdlib and time. And time, I guess, is used in srand. Okay, so let's do that first. And let's set here srand time null so that we will actually initialize the random number generator so it's actually random, because otherwise it's the same number every time. And basically for each of the rows that we loop through, we have to get a random row. So let's say int ry equals, and we have to pick from all the items that are left. So if we take rand, this is just a random number from 0 to rand max. And if we modulo it with a number, then it's going to be from 0 to that number because it's going to wrap around. And if we want to get it until the end, this is going to be grid size minus 1, I guess. Because if the grid size is 5, then the last index is 4. Okay, so this would be just from 0 to the last index, but we want it to be after the current y. So we have to say y plus, so that we don't pick one of the things that we already shuffled. So y plus, and what is then after that? Random until the end. Right, I guess that's correct. So we do that, and we do the same thing for x. So our x is going to be x plus random until the end. And then we have to swap. So we have to say vector to temp is going to be this one. And then that one is going to be shuffled rx, ry. And then we put it back. So then shuffled rx and ry is going to be the temp. So that should maybe work. And then we're going to have the shuffled, which we will use here instead of the ordering. So let's see if it works. Let's build it and let's run it. And what is going on here? So it seems like we randomly removed some pieces, but then all the other pieces are in the right place. That seems like kind of an off by 1 error. So where are we off by 1? I think we have to subtract y from here as well and x from here, because this will overshoot otherwise. Because let's say y is 4, we're in the last one. Then we're going to pick from y until a random number from 0 to 4, which is going to be too much. So we have to subtract this here. Okay, let's try again. Let's build it and run it. And now we got a floating point exception. Okay. Wait a minute. What does that happen? Do we get here to modulo 0? And is that a thing that's not allowed? If we try to do this, it actually said division by 0. And if we run it, then we get the exact same error. Okay, so how do we solve that? Is that why it's looping it backwards? But can't we do like y? So y is the smallest. We're not going to pick the same thing that we already calculated as a random one. we're gonna go from 0 until that. But can't we just do, instead of modulo, we can do divide by rand max. So then this is from 0 to 1. And then we times by this. So doesn't that get rid of the issue? If we do rand max times that. And do we need to again cast something? This should be a float. If we do that. So let's try to build this and run it. And now we have the same image. But why is it not random? How did we pick the same images or the same pieces every time? So yes, we pick a random piece and then we get that from a random location from the original image and we put it in the correct location on the screen. So the location in which we draw it on the screen should not be piece X or piece Y. This should just be the Y. So we should go in order on the screen and print every single piece, but then pick them from random place from the image. So if we do that, and then we run it, and we build it, what? Why is that not working? Impossible. How is shuffle the same as ordering? Let's print what these things are. So if I print F here, and I print RY, let's do like this, and then I also print the RX here, like that. And here I print just a new line. And then we compile it and we run it. Then everything is in order. 1, 2, 3, 4. 1, 2, 3, 4. What is this? What is grid size minus Y minus 1? If I print this, I build it and I run it, 4, 3, 2, 1. Okay, that makes sense. Does it go to 0? Yes. 4, 3, 2, 1, 0. So Y should be at first from 0 to 4. It should be a random number, right? What is this? Let's print that one. And that's a F. And build it and run it. So what is that? It is 0. So if I cast it to float like this, does that change anything? I build it and run it. It's still 0. Random integer. How do I make this a float? Do I in fact need to make these floats? Is that gonna do something? So many casts. Okay. We already got random rows. So that worked. Okay, so let's do the same thing here. So this needs to be cast into a float because it's an int, but this is an int as well. Okay, interesting. So let's remove our prints and let's do this stuff over here. And let's remove this print and let's build it and let's run it. And that in fact looks pretty shuffled, except for this. These are all in order, but is that just random? Okay, now it looks more random. Okay, I think it worked. I'm not sure if it's as random as it could be, but it seems pretty random. So I think I'm pretty happy with that. Like, all of these seem like they're part of the same thing. But is that just randomness? And this too, like, these are together, these three pieces. Anyway, it seems to work pretty well. Now, one thing I'm noticing here is that the last row is actually not as tall as the other ones. And that is because of our padding. So we have to take that into account. So if we go here, we have the padding here, which means we need to calculate the destination based on the padding. So let's define the padding here, and this should be window height minus padding times grid size minus 1. So this is going to be height. Let's call it height. Height. And let's set that here. Int height is this. Okay, let's see if that did it. So let's build it and let's run it. And I think that's correct. It seems pretty good. Okay, and let's see if it works with more pieces. So if I put grid size 10 and then I run it, then it in fact works. And that's a pretty difficult puzzle. So then, how do we move around the puzzle pieces? I want to use the arrow keys for that. So we should be able to pick a puzzle piece we want to move, and then we should be able to swap it with another one. I guess that is how it should work. So maybe we use the arrow keys to highlight one of these pieces, and I don't know, press Control and left to swap it with the left one, and Control up to swap it with the upper one, and then so on. I think that makes sense. So let's try to do that. Let's make it 5 by 5 again. And we should have some sort of highlight. So I want to have like a yellow border on the piece that is highlighted. And I guess the easiest way is to just make a yellow rectangle and put it behind the image, since we have the padding there. So if we make the yellow rectangle bigger than the actual piece, then it will look like it is a border around the piece. So let's create that. We have to, in the loop, after we clear the background, we have to draw a rectangle. And how do we do it? We give it the position X. And I want it to start from the middle. So how do I calculate the position in the middle? First, we have to take our magical number with the X origin, which I think actually it's just X origin. So we start with X origin, which is going to be the left side of the image. And we have to add to it grid size divided by 2 times the piece width. So what is the piece width? It is the piece size dest X. So let's do that like this. And does this actually take the integer? Yes. So this should be converted into integer, I hope. So maybe it works just like that. And the Y position should be just starting from 0. So it should be grid size divided by 2 times the piece size dest Y. So the height of a piece. Okay, maybe it works. And then the width is going to be piece size dest dot X plus padding times 2. And the height is going to be piece size dest Y plus padding times 2. And we in fact have to subtract from the X the padding times 2. And from the Y we have to subtract, sorry, not this one. This is the first one. Then we have the Y. Then we have the width and we have the height. So this should be minus padding plus that. I mean, what is the best way? Padding times 2, like this. And then the color is yellow. Okay, does it make sense? Let's build it and run it. And it's almost there, but not quite. So I have to include the padding in... Okay, so what am I doing here? So we start with the X origin and we remove padding, just one padding from that, right? And then we add grid size divided by 2, so half of the number of grids per X-axis, times piece size dest X plus padding. So this has to be included in there. So let's move the minus padding in the end. And this is the same thing. So grid size divided by 2 times piece size dest Y plus padding. Minus padding just once. Okay, and the width is that. Let's try again. Okay, it's there. It's kind of seems like it's 1 pixel off. Why does it seem like that? That's a bit annoying. Is it 1 pixel off or what is the issue? If I add +1 to the X axis, then there's 1 pixel here. Okay, so if I add 1 pixel here to the width, then it's gonna look correct. Okay, but why? I don't know why. Anyway, let's make it move around when we press the arrow keys. So we should in fact have a position for the highlight. So let's say vector2 highlight is going to be a vector 2 of what? Of grid size divided by 2 and grid size divided by 2 to begin with. So here we're going to say highlight.x, and here we're going to say highlight.y. And then we can just change the highlight to a different position. So we can say here, I guess we can do it before we start drawing. So if is key pressed, and if we press key left, what will happen is that highlight.x will minus equal 1, but only if it is more than 0. So if highlight.x is greater than 0, then we will subtract from it. And let's do else if we press right, then we plus equal to this if it is less than grid size. Minus 1, I guess. And what else? Then we want to have key up, which will modify y if y is less than or is greater than 0. And then if the key is down, then if y is less than grid size minus 1, then y plus equals 1. So now, if we build it and we run it and we click left, it moves left. If we press up, it goes up. If we press right, it goes right. And we press down, it goes down. So now we can move around. And what if we press and hold? Nothing happens. Okay. I'm not sure if I want something to happen or not. But yeah, now we can move around. So then I want to make it so that when I press Control and right, then it will flip the pieces around. Okay, let's do that. So what is the best way of doing this? Can we say if is key pressed? Oh, actually we have to say is key down. And we have to say key control, left control. Then we do something, and else we do all this stuff. Maybe that is the way to do this. And let's in fact copy the whole thing and make the logic here. If we press Control and we press left, then we need to modify our shuffled array so that we will flip around the current piece, the highlighted piece, with the one on the left. So how do we do that? We have to say that the shuffled highlight.y x is going to have to be saved. So the vector 2 shuffled highlight y x expression must have an integral type. Let's see what this will do. Oh, it's a float. So maybe we shouldn't have a vector 2. I mean, we can say int like this. Okay, let's do that. So that is going to be saved. So vector 2 temp is that highlight x. We save what is in x, and this has to be an integer again. And then we set a new value to this, which is going to be shuffled highlight y highlight x plus what? Sorry, minus 1. But again, we have to check this. So if we are in the leftmost piece, then nothing should happen, I guess. Let's do that. And then we have to set this one to the temp. So we flip them around. Okay, and we do the same thing over here. But this has to be now plus 1. And in the y-axis, we are going to do y minus 1 and just have it as x. Sorry, not like this. This is going to be y minus 1, and this is going to be x, and this is going to be y minus 1, and that is x. And over here, it is going to be plus 1. Okay, let's see if it works. Let's build it and let's run it. And if I want to flip these around, I press Control and right. What? What is happening? Okay, I'm pressing right. Why do those change? Maybe this index starts from 1. Okay, and wait a minute. When I press right, then y x is y and then x plus 1. Interesting. Okay, what if I press Control up? What? That's weird. Okay, so we have an off by 1 and then we have some weird thing. Did I save it as x and y? I did. Okay, so I just started the loop with y, but then I save it as xy. Okay, let's flip these around. So this needs to be like that, and this needs to be like that, and I will do all of these. Okay, and I think we have an off by 1 error as well, but let's build this and let's run it. So now, if I want to flip these, okay, actually it works. So when I press left, it will flip these. When I press right, it will flip these. But actually I want to move the highlight as well. Now that I try it, I realize that that's what I want to do. So if I'm pressing Control, I want to move the highlighted piece to the direction and then highlight that piece. Okay, so I guess we don't need this if-else block. We have to have that in each of these. Okay, so that means we take this if and we move this one indent back, and we can remove this part. And here in each of these, we need to check if the key left control is pressed or down. Then we're going to do this. Otherwise, we are just going to do not else, just that. And then if, every time we press left, then the highlight changes. But only here. So how does this work? Damn it. If we are not in the leftmost thing, then we are going to do this, and we're going to move the highlight. So highlight dot highlight dot x minus equals 1. That's the logic. And there's something extra somewhere now, like this. If we press left, then if we are not at the leftmost thing, then if left control is down, then we're going to flip them around. Otherwise, we are only going to move the highlight. Okay. And then we're going to do the same thing here. So this if, and then highlight dot x plus equals 1. And here, we're going to do this if the left control is pressed, and otherwise we are going to, or always, we are going to do highlight dot y minus equals 1. And finally, here we're going to check the control again, and then highlight dot y plus equals 1. Okay, I think that makes sense. Let's build it and run it. And now, if I pick the mouth and I move it left, it is going to move left until we get there. And then, if I move it right, it moves right. And I can do up and down and left and right. Okay, now we can move them around. So then, we can just find the right pieces from here, and we can put... Wait a minute. What? What is this? Why do we have two mouths? It's not... Wait a minute. Am I copying something when I do this? It changes the wrong thing. Wait a minute. Wait. Here we have some hair, and here we have empty wallpaper. If I press Control and I move this up, it gets another picture there. What is going on? Okay, let's try again. If we run it and I pick the mouth and I move it left, right, left, right, left, right, then this seems to be working just fine, right? It's fine. If I move the eyes, that works. So left and right works fine. But if I do down, down works fine. What if I take this and I move it up? Okay, up doesn't work. So key up is where? It's here. And this is going to take highlight X and highlight Y and save it in temp. And highlight X and highlight Y is going to be highlight Y minus 1 and highlight X. And okay, this is still Y. This should be X. and y, this way. Okay, let's build it and run it. And now I can move this thing around and it should work just fine. Does it work just fine? I think. So the face should be somewhere around there, like this, and this beard should be here, mouth is here, and this is here, and like this, and this should be there, like that, and beard is here, that's there, and this is there, that's there, this is probably here, that's like that, and then just these are impossible to find the correct place. This is down there. Okay, so now we can move around the pieces, but now we should be able to check whether the pieces are in the right position. So let's do that. Let's make a function for this. Let's do int. I mean, I guess it should be like bool, but I think we don't have bool by default. Does it come from stdlib or something? Can I go to definition? std bool. Okay, but do we have std bool? Does that come from somewhere? If I remove this, I think bool is always, like VS Code finds bool every time. Let's see if it's bool. And puzzle, what's the word? Puzzle, correct. Let's do just, puzzle is correct. And we need to pass in here a pointer to the vector2 of the basically ordering, and then the shuffled. So what should I name this? Let's say correct and vector2 current. And what we want to do here is we want to loop through the correct one and check against the current one. And do we have to say pointer to a pointer because it's a double or two-dimensional array? Or do we just do something like this? I don't know. What's the difference? I have no idea. But then we have to pass in the size as well, because otherwise we don't know it. I feel like this is correct if I do like that. And then let's do int grid size. So then what we can do is for int I is 0, I less than grid size, I plus plus. And we are going to say if correct index I. Sorry, we have to also then loop through it again. So let's call this y again, and let's call this x. And if correct x y is not current x y, and we have to dereference this because it's a pointer, right? We have to do this. Okay, but we can't do this because it's a vector 2. Okay, so what we actually have to do is we have to say if correct x y x equals current x y x, and correct x y y equals current x y y. So this one is going to be a vector 2. Let's call it C. And this needs to be dereferenced, I believe. How do we do that? Can we do this? No, because this only applies to a pointer. So we have to dereference correct, which is a pointer. So then, nope, not correct. Damn it, this is hard. Is it just a, can we just have a pointer to a, wait a minute. But it is not a pointer to vector 2, it is a, what the hell is it? It's this. Okay. So isn't this like a pointer to a vector? So how do I get the thing? Expression must have pointer to object type, but it has type vector 2. Okay, let's go to ChatGPT. How do I pass a two-dimensional array to a vector 2 into a function? Does that make any sense? Passing two-dimensional array with fixed size. Okay, we can just do this. Can I pass them in like that and then... okay, that makes sense. Passing a two-dimensional array with a variable size. Okay, well, I can do this. That makes sense. Here's just a pointer. It's just a pointer to the array. but it's not an int there, it's a vector 2, but doesn't matter. But basically we can take it from there, I plus cols plus j. Okay, so can I just do this? Can I say vector 2 correct grid size, and then I can do this the same way, which is current grid size, and we have to pass in the grid size first. Then I can use it here. Is that correct? Aha! Interesting. So then I can say that the C is going to be correct XY. So then I can remove this and replace it with C. Let's call it cor for correct. And this is now just a dot because it's not a pointer. And this is cor. And then I'm gonna get cur, which is current. And this is cur. So if the correct, this also needs to be removed. Okay. If the correct X is the same as the current X, and the correct Y is the same as the current, anyway, if they're all the same, then we're going to do something. We should say if it's not the same, or this is not the same, then we return false. And in the end, if we didn't return false, then we're going to return true. Okay, but what is the issue here now? I think VS Code is just being slow. So I'm assuming that this works now, and I'm going to copy this function. And every time what's happening here? Let me reload VS Code. Okay, now we have no errors. So then, every time we flip them around, we should do this. Puzzle is correct. And we have to get the grid size. So we have to define that. We actually defined it already up there. So we have to check with the grid size, and we have to pass in the ordering, and we have to pass in the shuffled, and we can say if puzzle is correct, then we should say congratulations or something. So let's do this in begin drawing, and let's clear the background. I mean, what should we do when the puzzle is correct? I kind of want to set the padding to 0 then. So then the pieces come together. And maybe we can then not draw this rectangle. So only if the puzzle is not correct, then we draw the rectangle. And I guess we don't have to check the puzzle is correct every frame. So we can do something like this. We can define in the loop a Boolean changed pieces to false, and then if we actually change the pieces, then we say changed pieces is true. So now we can only check if we change the pieces. So if changed pieces and puzzle is correct. And in fact, we should do something like this. If we change the pieces, then we check if the puzzle is correct. Then padding is going to be 0. And we should kind of save the state. So can we say here, in fact, out of the loop, we can have a Boolean, puzzle correct is false. And then we can say that puzzle correct is true. Otherwise, puzzle correct is false and padding is whatever the original padding was. And then this one we are going to say if not puzzle correct, then we draw the highlight. Okay, it seems a bit too complicated, but something like this we have to do. Let's try it with just a 2x2 grid. Does it now work? Let's build it and let's run it. And that's correct already. So it worked. Let's try again. Run it, and it's still correct. So maybe we want to actually check on the first iteration. I mean, I don't know, man. That's kind of stupid. But why is it correct every time? Every single time it's correct. That's very weird. Maybe in my shuffling there's some issue. So let's do 3x3 then. Hopefully that will then a little bit at least shuffle them. Okay, So now we are shuffled. But if we move this piece over here, then it is correct. Amazing. Now can we still move? We can still move. It just doesn't highlight it. Okay. But that's pretty cool. So let's do 4x4 and run it. Why is it so easy? It's too easy. I think there's something wrong with my shuffling. But if we now find the correct solution here, this should be there and this should be there, then it is done. Now I don't quite like that it is not all the way to the bottom now when it shows the whole image. And that is because we calculate the height here based on the padding. So do we need to in fact move this calculation and this calculation too inside of the loop over here? Can we do that? Do we use any of those variables up here? I don't think we use those. But padding we can set up here. So now if I run it, then it still looks fine here. It goes, does it go all the way to the edge? Yes. Not quite. It almost goes there. Wait. I would say it goes to the edge. It's good enough. But if I now order this properly, then it should snap into place in such a way that it will look proper. So let's do like this. Okay, so now it snaps into place and we remove the highlighting and everything. Great, only took me 3 hours to build this thing. Let's try it with another image. And let's actually take the image from the command line. So we can do something like this. We have to pass in, how does this work? Is it like char star star arg argv and int star star argc, or is it char argv like this? I forgot. And then this can be argv0. Or can we just do the same thing here? Can we do this? I don't know. I think I've seen it like this. Not 0. 0 is the program name, so it should be 1. And we should say if... Actually, what am I doing? argc is just the number. So it's either like this or like that. Or maybe argc is first. Let's see. Who knows? If argc is less than 2, then we have to do something like fprintf error no image provided and a new line, and we have to exit or just return return 1 because it's an error. And this actually takes in the stream. I forgot how this works. Do we have like an std error? Can we do that? And then if I build it and I run it, it says no image provided. And I guess we can say usage is this, which is the program name, and then we have to have the image file and a new line, and we pass in here argv0. So if I now build it and I run it, we get a segmentation fault. So maybe it's the other way, argc and argv. This is how basic my understanding of C is. Let's run it. Okay, that's the way. argc, argv. And it says no image provided, usage, main, image, file. Awesome. So if we then do main and we give it the dude.png, then it actually opens it. And then we can move these things around. And that is pretty cool, I would say. And of course we get an error if we try to use the JPEG. So we might want to check that error. So when we load the image, where did we actually get warning? Image is not valid to load texture. Data format is not supported. Okay, so this one returns a pointer. So then we can do something like if image is null, then we can do fprintf std_err and error image image format not supported. Try png and a new line and return 1. And in fact, this returns an image, so it's not null. So let's go to the definition of this. And there's probably some error thing. So what is the error? How do errors work in Raylib? So image is going to be this kind of thing. So I guess we could check the data. That's probably not the right way. We could say if image data is null, then we get an error. So if we build it, if we build it, and then we run it, it gives an error. But if we run it with dude.jpg, it says image format not supported. But it still prints all the Raylib errors, which is not that nice. But what if we now use PNG? Then it works. Okay. I do want to check what is the correct way of doing that. How do I check errors from Raylib's load image function? In Raylib, the load image function returns an image struct. Okay. However, it doesn't provide a direct way to check for errors. Instead, you need to check the data field of the returned image struct to determine if the image was loaded successfully. Okay. Well, I did it properly then. I'm pretty proud of myself. All those hours watching coding have really paid off. Okay, let's try it with some other image. So let's create one with ChatGPT. Create an image of a group of wild animals. Okay, and these are very puzzle-like. So let's take this one and download it. And let's copy it here. Let's cp from downloads DALL-E 2024-06 and let's do animals.webp and I will convert animals.webp into animals.png. And then we can run main and we can do animals.png. And here is our image or our puzzle. So let's try to solve this puzzle. Let's put the lion there. This needs to be there. And elephant was somewhere around here. Let's put the trunk here. And this guy should be somewhere. And those are its legs. This should be like that. This guy should be there. That should be there. And what else? What is this? Let's move this over here and that over there. And what is wrong with this? The lion should be like this. So that should be that way. And maybe the lion was all the way there. And what on earth is this? Haha! I did it. It works. That's pretty cool. So in the next video, if there is a next video, let me know if you want the next video. I would like to add, first of all, some animations to this. So that when we move around, can we still move around? Yes. So when we move the puzzle pieces, they would actually animate when they switch. And maybe add some drag and drop feature where we can just drag our own image there and then it will change to that one. And maybe the error could be also like shown on the screen. And maybe we can have a timer or something. I don't know. Let me know in the comments how I should develop this game further. And if you have any other game development ideas, let me know in the comments. And make sure to subscribe so you don't miss the next video that I post. Thanks for watching and I'll see you in the next one.